Have you ever truly looked at the night sky? Not just a fleeting glance, searching for a familiar dipper or a warrior's belt, but truly gazed into that velvety, bottomless, coal-black expanse and asked yourself the simplest, most childlike, most obvious question in the world. Why is it dark? You probably scoff. What foolishness. Night is dark because the sun, our personal cosmic spotlight, has set below the horizon, turning to the other side of the planet. Its light no longer floods our atmosphere, nor is it scattered within it, painting the celestial dome a cheerful azure. Logical, undeniably so. Cozy, understandable, and utterly insultingly incorrect. Or rather, it's merely a tiny fragment of the truth. A drop in the ocean, a grain of sand on the boundless shore of cosmic reality. This convenient, domestic logic only works here, on the doorstep of our earthly home. But step beyond that threshold, even in thought, and it crumbles to dust. Let us take that step. Our sun is merely one star, one of, by the most modest estimates, hundreds of billions of stars that dance in the colossal round of our galaxy, the Milky Way. Imagine that. Hundreds of billions of suns, some dimmer than ours, others 1,000 times brighter. Some are blue giants, burning with furious, unyielding fire. Others are red dwarfs, smoldering like eternal embers. All of them form a gigantic, luminous disk, a phosphorescent vortex so enormous that light takes 100,000 years to traverse it from end to end. We live on its quiet periphery, in a provincial spiral arm. But even from here, on a clear night, we see its radiant core as a pale, hazy band in the sky. We are looking at our own galaxy from the side, and even this small portion of its light is already mesmerizing. But wait, this is only the beginning. Our Milky Way is not the entire universe. It is merely one city in a giant metropolis, one island. Beyond our stellar home lies an ocean in which swim other galaxies. Not thousands, not millions. According to the latest data, obtained thanks to the inquisitive gaze of space telescopes, there are trillions. Trillions of islands of light, each of which, like ours, consists of hundreds of billions of its own stars. Some of them are our neighbors, visible even to the naked eye as hazy specks. Others are so distant that their light has traveled to us for billions of years, beginning its journey when life on Earth had not yet even begun. And now, let us put it all together. Hundreds of billions of stars in our galaxy, trillions of galaxies in the universe. The number of lights in the cosmos is so immense that our minds refuse to comprehend it. It exceeds the number of grains of sand on all the beaches and in all the deserts of Earth. It is literally an ocean of fire. And here we approach the abyss, the real mystery that has troubled astronomers and philosophers for centuries. Imagine you are standing in the middle of an infinite forest, not just a large one, but truly infinite, stretching out in all directions. Yes, into eternity. You look in any direction. Right in front of you are tree trunks. They appear large and distinct. A little further, other trees. They are smaller and less bright. Even further, their trunks almost merge into a solid wall. But since the forest is infinite, no matter where you point your finger on the horizon, your line of sight will inevitably meet the trunk of some tree. Near or far, it doesn't matter. What matters is that there should be no empty spaces. Your entire view should be filled with the solid, impenetrable texture of tree bark. You should see nothing but trees. Now, let's replace the trees in our thought experiment with stars, and the forest with the universe, which we, until recently, considered infinite and eternal. Wherever you look in the night sky, in every tiniest spot, your gaze, piercing through space, should sooner or later encounter the surface of a star. Yes, distant stars are dimmer than nearby ones. Their light weakens proportionally to the square of the distance. But here's the catch, which turns this problem into a real intellectual trap. The further we look, the more space enters our field of vision, and the number of stars in each subsequent layer of space increases precisely enough to compensate for the weakening light from each individual star. Simply put, myriads of dim, distant stars should shine as brightly as a handful of bright nearby ones. If you add up the light from all these infinite layers, from all these trillions of galaxies, from all these countless suns, the result is the same. Not just a bright sky. The sky should blaze, It should shine with the brightness of the surface of an average star. The entire celestial sphere, from horizon to horizon, day and night, should be a blinding, all-consuming, incinerating white canvas. The night sky, as we understand it, simply shouldn't exist. We should be living inside a giant, infinitely heated furnace. But we don't observe this. We go outside, look up, and see darkness, calm, cool, peaceful darkness, occasionally pierced by the diamond pricks of individual stars. Here it is, the great paradox. A simple childlike question, why is it dark at night, turns into a gaping crack in the very foundation of our understanding of the world. It calls into question everything that seemed obvious, the infinity of space, the eternity of time, the static nature of the cosmos. It tells us that either our logic is flawed or our conception of the universe is a profound delusion. This mystery, known in science as the photometric paradox, not just a curiosity, it is a key that unlocks the door to the most secret rooms of cosmology. It is a thread which, by pulling, unravels the tangle of the greatest discoveries of the 20th century. It leads us directly to the moment of the universe's birth, to its incredible expansion, to the nature of light and time itself. So, forget for a moment the cozy answer about the setting sun. It's no longer helpful. We embark on a journey where darkness is not the absence of light. Darkness is the main character. It is the narrative. It is a historical document written in the language of the universe itself. And to read it, we will have to abandon our usual truths and prepare ourselves for the reality to be far stranger and far more beautiful than we could have imagined. A simple question requires a complex answer. And the answer is not just a fact, it is an entire saga, a saga of the birth, life, and very nature of reality. And it begins here, in this calming, deceptive darkness. So, we stand before a gaping abyss, stretched between our everyday experience and the cold logic of numbers. The question of the night sky has ceased to be an innocent childhood riddle. It has turned into an intellectual chimera that has tormented the greatest minds for centuries. And this chimera has a name, given to it in honor of the man who not only encountered it, but looked it straight in the eye, describing it with merciless mathematical precision. His name was Heinrich Wilhelm Olbers. He was not a cloistered philosopher, lost in abstract clouds. He was a doctor from Bremen, a man of practice, and at night, a passionate and meticulous astronomer, a discoverer of asteroids and comets. He was a man who believed in what he saw through his telescope, and it was this belief in observable facts that clashed with the iron logic of his era, giving rise to one of the most profound crises in the history of science. Olbers did not invent this paradox, but he transformed it from a vague unease into an official ultimatum thrown at the entire cosmos. He built a perfect trap for the human mind. And to understand its insidious design, we need to carefully examine its three supporting walls, three fundamental assumptions that, in the early 19th century, seemed not just true, but self-evident, like the sunrise. The first wall of this mental dungeon is the belief that the universe is infinite in space. This idea was not just a scientific hypothesis, it was the philosophical banner of the Enlightenment, a triumph of reason over ancient fears. We had just shed the claustrophobic shackles of a world where Earth was the center, and stars were lanterns nailed to a crystalline sphere. By abandoning the center, we logically came to abandoning the edge. After all, what is an edge? A wall? And what is beyond it? Asking such questions seemed childish, a return to mythology. An infinite, homogeneous universe, governed by a single law, was the height of elegance and simplicity. It was the universe of Newton and Laplace, majestic, predictable, boundless. Any other concept seemed a concession to the irrational. Infinity was synonymous with freedom. Freedom from theological frameworks and anthropocentric illusions. It was a blank canvas on which science could write its universal laws. The second wall, no less strong and imposing, is the eternity of the universe in time. The thought that the world had a beginning, a moment of creation, smacked of old tales and seemed unscientific. The universe was conceived as a gigantic, perfectly tuned clockwork mechanism that didn't need winding. It just ticked, always, from eternity to eternity. Yes, Individual parts of this mechanism, stars and planets, could be born and die, but the mechanism itself, the very fabric of space and time, was considered immutable, static, and eternal. This concept of static eternity solved many inconvenient questions. There was no need to explain what existed before the universe or where it came from. It was a given, an axiom. It was the perfect cosmos for physics, which sought to discover eternal laws governing eternal matter. The universe was like a river without a source and without a mouth, simply flowing. And finally, the third wall, completing this flawless logical construction, is the assumption of the uniform distribution of matter. Of course, astronomers saw that stars grouped into constellations, and the Milky Way formed a dense band in the sky. But this was about the cosmological scale. It was assumed that if you took a very large cube of space with sides of millions or billions of light years, the average number of stars within it would be approximately the same, wherever you place that cube. This is the so-called cosmological principle. On large scales, the universe is homogeneous and isotropic, meaning it looks the same in all places and in all directions. Without this assumption, any attempt to extrapolate our local observations to the entire universe would be doomed. It's like studying the chemical composition of the ocean by assuming that the salinity of the water in your bucket is roughly the same as in any other bucket scooped thousands of kilometers away. So, here they are. 3 pillars of classical cosmology, 3 axioms that seemed unshakable: infinite space, eternal time, and stars uniformly scattered throughout this space. Each of them individually sounded like a hymn to reason. But Olbers showed that, brought together, they generated a logical nightmare. He invited us into the innermost circle of hell for logic. Imagine yourself as an observer, a point at the center of this infinite, eternal, and homogeneous universe. Now, let's draw a mental line, outlining a thin, spherical shell around ourselves, say, at a distance of 100 light-years. Within this shell, like raisins in a bun, are a certain number of stars. Each sends us its ray of light. Collectively, they create a certain brightness. Now, let's draw a second shell twice as far away, at a distance of 200 light-years. This is where the devilish arithmetic begins. This second shell has a much larger surface area. According to the laws of geometry, its area will be 4 times greater than the first. And since the universe is homogeneous, there will be approximately 4 times more stars in this shell. A 4-fold increase in the number of light sources. It would seem the sky should become brighter. But another law comes into play. The law of optics. The intensity of light from any source decreases proportionally to the square of the distance. Anyone who has walked away from a campfire in a dark forest knows this. Take 2 steps, and you notice a significant decrease in heat and light. A star at a distance of 200 light-years will be 4 times dimmer to us than an identical star at a distance of 100 light-years. And here, the trap snaps shut with a deafening click. A perfect, sinister compensation occurs. The more distant shell contains 4 times more stars, but each of them shines 4 times dimmer. One effect precisely cancels out the other. As a result, the total light flux arriving at us from the second distant shell is absolutely the same as from the first, nearby one. This in itself is strange, but it gets stranger. Let's take a third shell, 3 times as far away. It will contain 9 times more stars, but each will shine 9 times dimmer. And again, the same result. This layer contributes exactly the same amount to the overall brightness of the sky as the first, the second, and so on. The 4th layer, the 5th, the 1000th, the millionth. Since our universe, by the conditions of the problem, is infinite and eternal, meaning the light from the most distant stars had an infinite amount of time to reach us. We can draw these shell layers to infinity, an infinite number of layers, and each of them, whether it is close to us or unimaginably far away, adds the same non-zero portion of light to the total. What will we get if we sum an infinite number of identical finite quantities? There is only one answer: infinity. This is not a poetic metaphor. It is a rigorous and inescapable mathematical conclusion. The sky should not be just bright. Its brightness should be infinite. The entire celestial sphere, every point of it, should radiate with the blinding brightness of the sun's surface. We should be living inside a colossal white-hot furnace. The coolness of night, the velvety darkness, the twinkling of individual stars. All of this should have been physically impossible. Here is Olbers' Paradox in all its terrifying grandeur. It was a verdict passed on the entire worldview. It was the moment when the most elegant and beautiful scientific theory produced the ugliest and most absurd prediction. The gap between logic and reality was absolute. The theory predicted complete incineration. Reality showed us calm, cool darkness. This darkness ceased to be a mere background. It became a silent but deafening accusation. It screamed that at least one of our fundamental conceptions of the universe, infinity, eternity, or static nature, was a catastrophic error. The trap for the mind was set, and it was flawless. The only question was which of the three walls we would have to break to escape it, and what the price of that freedom would be. We are trapped. The steel walls of logic, erected by Olbers, have closed in on us, and escape seems impossible. Infinite space, eternal time, uniformly distributed stars, three axioms, each of which individually appears to be common sense, together create the absurd prediction of a white-hot universe. To escape this intellectual prison, we don't need a key, we need a battering ram. We must bring down one of the walls, but which one? Which of these fundamental truths do we dare to declare a lie? Let us begin with the most audacious, the most blasphemous idea for the classical scientific mind. Let us encroach upon eternity itself. What if the universe had a birthday? In the 19th century, and even in the early 20th, this thought sounded like a surrender, a return to mythology, to the book of Genesis. To the idea of divine intervention, science sought to expel any hint of a singular, unique act of creation from cosmology. An eternal, unchanging, static cosmos was its ideal. But science, in its relentless movement, sometimes arrives at conclusions that sound like ancient prophecies. And the greatest discovery that changed everything began not with loud pronouncements, but with the quiet scratch of a pen on paper, with mysterious symbols in the equations of Einstein's general theory of relativity. The great physicist himself, upon formulating his theory of gravity, discovered with horror that it predicted something unthinkable. His mathematical model of the universe was unstable. It could not simply stand still. It had to either contract under its own gravity or expand. This dynamic so frightened Einstein, so contradicted his philosophical beliefs about a static world, that he committed what he later called his greatest blunder. He artificially introduced a special cosmological constant into his equations, some kind of anti-gravitational force, to prevent his model from collapsing or flying apart. He forced the universe to stand still because he could not believe it was moving. But the seeds of doubt were sown, and they sprouted in the mind of another genius, a Belgian priest and astrophysicist named Georges Lemaitre. This remarkable man, who saw harmony, not contradiction, between his faith and his science, was not afraid of the implications of Einstein's equations. He took them seriously. If mathematics says the universe is dynamic, then so be it. And if it is expanding today, then, Lemaitre reasoned, by rewinding the film of time, we must arrive at a moment when it was smaller, even smaller, and still smaller. Eventually, all the matter and energy of the universe must have been compressed into a single, unimaginably tiny and dense point. Lemaitre called it the primeval atom. He proposed that the entire history of the cosmos is the story of the decay, or rather, the unfolding of this original unity. This was not just a hypothesis. It was the first sketch of the theory that we know today by the somewhat flippant name, the Big Bang. The idea of a birthday for the universe ceased to be a myth and became a scientific prediction. Today, after decades of observations, measurements, and calculations, we can state the date of this event with astonishing accuracy. The universe has an age, and it is not infinite. It is approximately 13.8 billion years. This is not just a beautiful number. It is a number etched into the very fabric of reality, confirmed by numerous independent methods. From measuring the speed at which galaxies are receding to analyzing the cosmic microwave background radiation left over from that fiery era, 13.8 billion years. Think about that. It's a very long time by human standards, but it's not eternity. It's a finite, measurable period. And this simple fact, the finite age of the universe, deals the first crushing blow to Olbers' Paradox. To understand how, we need to call upon another fundamental hero of our story: light. Or rather, its speed. The speed of light in a vacuum is not just a very large number. It is an absolute limit, a cosmic dictator, the strictest law in all of physics. Nothing, no matter, no information, not even the influence of one event on another, can travel faster. The speed of light is not a speed record that can one day be broken. It is the very speed at which causality propagates through the universe. It is this finiteness of the speed of light, combined with the finiteness of the universe's age, that is our battering ram. When we look at the night sky, we perform an act of archaeology. We are looking into the past. Light from the moon takes a little over a second to reach us. We see it as it was a second ago. Sunlight takes a little over 8 minutes. The star closest to us, Proxima Centauri, is a little over 4 light-years away. We see its light, emitted 4 years ago. The Andromeda Galaxy, our closest large neighbor, appears to us as it was 2.5 million years ago, when our distant ancestors, the Australopithecines, roamed the Earth. Light from more distant galaxies has traveled to us for billions of years. We see them as they were when the universe was still young. And now, let's put it all together. If the universe is only 13.8 billion years old, it means that we physically cannot see anything that is farther away from us than 13.8 billion light-years. Not because there is nothing there, but because the light from there, from these hypothetical, even more distant galaxies, has simply not yet had time to reach us. It is on its way. It is traveling through space and time, but its journey is not yet complete. This creates an invisible but absolutely real boundary around us, a cosmic horizon. This is not a wall to crash into. It is a temporal barrier. It is the limit of our observable universe, even if the universe itself is infinite in space, and this is a question that remains open to this day, the part of it that we can in principle see. Of course, its radius is equal to the age of the universe multiplied by the speed of light. Now let's return to Olbers' nightmare, to his infinite series of luminous spherical shells. What happened to it? Our new cosmology cuts off this series without any pity. We can still draw our mental spheres. The first sphere, the second, the 100th, the millionth. But we cannot continue this process to infinity. Reaching a distance of 13.8 billion light-years, we hit a wall. Not a brick wall, but a wall of time. Darkness beyond. Not because there are no stars there, but because we see this region of space as it was at the very moment of the Big Bang, when stars did not yet exist. We are looking into the infancy of the world, into the era before the birth of the first celestial bodies. The infinite sum, which in Olbers' calculations led to infinite brightness, has turned into a finite sum, huge but finite. We are summing light not from an infinite number of shells, but from a perfectly definite number of them. And a finite sum of finite quantities always yields a finite result. The paradox is falling apart. Its mathematical heart, the idea of infinite summation, has been stopped. Imagine our infinite forest again. But now let's add one condition. This forest is not eternal. It miraculously grew only an hour ago. You are standing in its center. You see trees around you. You see those that are 100 meters away and those that are 500 meters away. But you cannot see a tree that is 300,000 kilometers away, even if it is there. Why? Because light from that tree, traveling at the speed of light, would take a whole hour to cover that distance and reach your eyes. Your visible world is limited by a sphere with a radius of 1 light hour. Beyond this horizon, an infinite forest may stretch, but for you, here and now, absolute darkness reigns there. Darkness not of absence, but darkness of anticipation. Here it is, the first and most powerful reason for the darkness of the night sky. It is dark because we live in a young universe. We live in the echoes of cosmic morning. The darkness between the stars is not emptiness. It is the shadow of the past. It is a huge, tangible testament to the fact that our world had a beginning. Looking into this blackness, we are looking at the boundary of time. We see the echo of the moment of creation. The wall of eternity, one of the 3 pillars of the paradox, has collapsed, and through the breach in it, we have seen not just stars, but history for the first time. the history of a universe that has its own birthday. The trap is not yet fully disarmed, but its mainspring is broken. We have breached the first gap in the walls of the paradox. By acknowledging that the universe had a birthday, we have cut off the infinite tail of light from hypothetical to distant galaxies. Their rays simply have not had time to reach us yet. This is a powerful blow to Olbers' logic, but strangely enough, insufficient. If the finite age were the only factor, the sky would still be unbearably bright. Calculations show that the light from those trillions of galaxies that have still managed to get into our observable universe would be enough to make the night sky shine. Perhaps not like the surface of the sun, but certainly like a continuous bright fog in which both the moon and the brightest stars would drown. The darkness we see is much deeper and blacker than the young age of the cosmos alone can explain. There must be another mechanism, another cosmic sensor, that reduces the brightness of the universe, turning a potential conflagration into a scattering of cold sparks. And to find it, we need to break down the second wall of classical cosmology, the wall of statics. Let's return again to the beginning of the 20th century. While Lemaitre was deriving his theory of the primeval atom from Einstein's equations, on the other side of the Atlantic, at the Mount Wilson Observatory in California, another man was peering into the abyss, armed with the most powerful telescope in the world at that time. His name was Edwin Hubble. He was a former lawyer, an amateur boxer, and a war veteran, a man of iron will and incredible observational meticulousness. His task was to measure the distance to those faint smudges that astronomers called spiral nebulae and understand their nature. Were they clouds of gas within our Milky Way, or were they distant, self-contained island universes, as the philosopher Kant had suggested? Using a new method of measuring distances by pulsating Cepheid stars, Hubble proved the latter in the mid-20s. The Andromeda Galaxy and other similar objects are giant stellar systems comparable to our own, but located at colossal distances. The universe simultaneously expanded, turning from one star city into a metropolis with trillions of inhabitants. But this was only the first of his great discoveries. The second was even more astounding. Hubble did not just measure distances. Together with his assistant Milton Humason, he analyzed the light coming from these distant galaxies. He dispersed it into a spectrum like a rainbow and studied the dark lines in this spectrum, the fingerprints of the chemical elements that make up stars. And he noticed a striking, inexplicable pattern. In almost all galaxies, these spectral lines were shifted. They were not where they should have been according to laboratory measurements on Earth. They were shifted into the red, long wavelength part of the spectrum. This phenomenon, known as the Doppler effect, was well known to physicists. When the source of waves, whether it's the sound of an ambulance siren or the light of a star, moves away from an observer, the waves are stretched, their wavelength increases. For sound, this means a drop in pitch. For light, a reddening. The red shift in the spectra of galaxies meant only one thing. They were moving away from us, almost without exception. And this was incredibly strange. Why was the entire universe fleeing from us as if we were the center of a cosmic plague? But then Hubble took the next step. He compared his data, the distance to a galaxy, and the magnitude of its red shift, and discovered a law that immortalized his name. It turned out that there was a direct linear relationship. The farther a galaxy is from us, the faster it moves away from us. A galaxy twice as far away recedes twice as fast. 3 times as far, 3 times as fast. This was not a chaotic scattering, but an orderly, universal expansion. It is very important here to understand the essence of this discovery. It is not that galaxies are flying through empty space like shrapnel after an explosion. It is space-time itself, the very fabric of reality, that is expanding. Imagine an uncooked cake with raisins. Put it in the oven. The dough will start to rise, increasing in volume. For any raisin, it will seem that all the other raisins are moving away from it. Moreover, a neighboring raisin will move away not much, but one at the far end of the cake will move much farther in the same amount of time. It is exactly the same in our universe. Galaxies are raisins, and space-time is the dough. This expansion has no center. It happens everywhere and at once. Any observer in any galaxy will see the same picture. All other galaxies are scattering away from them. This discovery, the expansion of the universe, became the second battering ram that collapsed Olbers' paradox, and its impact was even more subtle and profound. What happens to light when it travels through expanding space? A photon of light emitted by a distant star billions of years ago is not just a bullet flying in a straight line. It is a wave traveling on the ocean of space-time. And if the ocean itself is stretching, then the wave traveling on it will also stretch with it. This is no longer just the Doppler effect. It is something more fundamental, which has been named cosmological redshift. The wavelength of light increases in direct proportion to how many times the universe has expanded during the travel time of that wave. And what does an increase in wavelength mean for light? According to the basics of quantum physics, the energy of a photon is inversely proportional to its wavelength. The longer the wave, the less energy it has. And here it is, the second mechanism for the dimming of the universe. Light from very distant galaxies, traveling to us for billions of years through the constantly expanding fabric of space, does not just fly, it gets tired. It loses energy. Each of its photons reddens, and its wave stretches. Light that was emitted in the visible, say, blue or yellow range, may turn out to be in the red part of the spectrum upon arrival. Light that was originally red will shift into the infrared range, invisible to our eyes. Ultraviolet radiation will turn into visible light, and the most energetic gamma rays and X-rays from the most ancient cataclysms will reach us in the guise of harmless radio waves. The universe acts like a giant cosmic dimmer, a brightness regulator. It takes the energetic, bright light emitted by billions of young stars in the distant past, and as it flies to us, it systematically reduces its energy, stretching it, spreading it over longer and dimmer waves. This explains why even those galaxies whose light has already reached us do not flood our sky with blinding brilliance. Their light reaches us weakened, faded, devoid of its original power. Imagine standing on the shore and listening to music coming from a ship far out at sea. If the ship is stationary, you hear the melody. If the ship sails rapidly away from you, all the sounds will become lower. The music will turn into a prolonged low hum. And if it sails away at colossal speed, then all the sounds will shift into the infrasound range, which your ear simply cannot perceive. You will see the ship, but for you, it will become absolutely silent. It is exactly the same with distant galaxies. We can see them with our telescopes, but their light is only a pale, stretched shadow of the furious radiance they emitted in their youth. Thus, the expansion of the universe deals a double blow to the paradox. First, it serves as empirical confirmation of the Big Bang theory. After all, if everything is flying apart, it means it was once together, reinforcing our first answer. And second, it provides a completely independent and incredibly powerful dimming mechanism. The wall of statics collapsed, and behind it, we saw not just a moving, but an aging and cooling universe. The light in it does not just fly, it lives, changes, and loses its strength with the passage of cosmic time. The darkness of the night sky is not only a testament to the birth of the world, but also an imprint of its continuous, majestic evolution. We stand on the ruins of the old world. Two mighty walls of classical cosmology, eternity and statics, have fallen under the blows of two great ideas of the 20th century. One told us that the universe has a birthday, the other that it lives, breathes, and grows, constantly expanding. Each of these ideas in itself deals a crushing blow to Olbers' paradox. But their true, stunning power is revealed only when they act together, like two brilliant investigators who, by combining their clues, finally solve the most intricate case. Individually, they give us partial answers, hints, half-tones. Together, they paint a complete, clear, and strikingly elegant picture of why the night is dark. Let's imagine for a moment that only our first answer is correct. Suppose the universe is indeed young, 13.8 billion years old, but at the same time, it is static and not expanding. In this case, as we have already understood, we would be protected from the light of galaxies located beyond our cosmic horizon. Olbers' infinite series of luminous shells would be cut off. But what about the light that is within this horizon? There are still trillions of galaxies within our observable universe, each of them a collection of billions of suns. Without the expansion effect, their light would reach us without loss, not counting the usual weakening with distance. And although the sum of light would no longer be infinite, but finite, it would still be colossal. The night sky would not be pitch black, it would glow like a thick, bright, uniform fog. We would live in a world of eternal white nights, where the brightest stars would be barely distinguishable against this radiant background. So, the finiteness of age is important, critically important, but it is not enough. Now let's imagine the opposite situation. Suppose the universe is eternal, but at the same time expands at the same rate as in reality. In this case, light from the most distant stars would have had infinite time to reach us. There would be no cosmic horizon related to age, but every photon, traveling through the eternally expanding space, would lose energy due to cosmological redshift. Light from very distant galaxies would be so stretched that it would turn into invisible radio waves. This dimming mechanism works excellently. However, in an eternal universe, there would be a problem of a different kind. Over infinite time, even a weak but constant influx of energy could accumulate and lead to paradoxical consequences. And more importantly, the very idea of an eternally expanding universe leads to a logical dead end. If we rewind time, we inevitably arrive at a state of singularity, i.e., a beginning. Thus, expansion itself hints at a finite age. These two ideas are inextricably linked. The true beauty of the solution is revealed when we allow both factors to work in unison. They do not just complement each other, they multiply their effect. To truly feel this, let's use a metaphor. Imagine that the universe is a giant postal service, and each star is a sender of letters. The letters in this case are photons, particles of light. You are the recipient, standing at your mailbox called Earth. In the old Olbers model, this postal service had been working forever, had an infinite number of senders, and the letters never spoiled in transit. Naturally, your mailbox should not just be overflowing, it should have been buried under an infinite avalanche of letters. Now let's look at how our two new rules change this picture. Rule number 1. The universe has a birthday. This means that the postal service opened only 13.8 billion years ago. You cannot receive a letter sent before this date for the simple reason that no one sent it. The postal service did not exist yet. This introduces a strict absolute limitation. All stars and galaxies that are so far away that their light would take more than 13.8 billion years to reach you. These are senders whose letters are still en route. They simply have not had time to arrive. Thus, the finite age of the universe acts as a giant input filter. It cuts off the overwhelming majority of potential letters, leaving only those sent from the observable vicinity. The infinite avalanche turns into a limited, though very large, stream of correspondence. This is the first key that limits the amount of light. Rule number 2. The great stretching of light. This rule concerns the quality of the letters that did reach you. The expansion of space-time is a bad postal service. In the process of delivery, it spoils the letters. Imagine that each letter is written in bright, clear ink on a snow-white sheet of paper. But during the long journey, the postman, space-time itself, constantly stretches the envelope along with the letter inside. What will happen to the text? The bright ink will fade, stretch, turn from rich black to pale, blurry gray, or even reddish. An energetic, clear message becomes weak and barely legible. It is exactly the same with light. A photon emitted as high energy, ultraviolet or blue, after billions of years of travel through the stretching universe, arrives at us as low-energy red or even invisible infrared. This is the second key that reduces the energy of each individual ray of light. Now let's combine them. The night sky is dark because, first, only the light from a small fraction of all existing stars in the universe reaches us, those that are within our temporal horizon. This is our first key. And second, the light that does reach us from distant objects arrives incredibly weakened, faded due to the expansion of the universe. This is our second key. One key limits the quantity, the other the quality. One acts as customs, not allowing too late cargo. The other as harsh transportation conditions, spoiling the cargo that has passed. Together, they create the effect that generates the deep velvet darkness of the night sky. The final conclusion sounds simple, but behind this simplicity lies a whole revolution in our understanding of the world. The sky is dark, not because there are few stars. There are unimaginably many. The sky is dark because the universe is young and dynamic. Darkness is not emptiness. Darkness is a giant clock showing the age of the world. Darkness is a giant speedometer showing its expansion rate. Every time we look at the black velvet of the night, we see direct, irrefutable evidence of the Big Bang and the expanding universe. Olbers Paradox, this old intellectual trap, has turned into its opposite, into the most visual and beautiful exhibit in the Museum of Modern Cosmology. In every good detective story, there is a red herring. There is a suspect to whom all the evidence points, whose guilt seems obvious, simple, and as logical as can be. It elegantly explains all the inconsistencies, and the investigator, succumbing to temptation, is ready to close the case. In our story about the darkness of the night sky, such an ideal suspect was cosmic dust. The idea that it is responsible for hiding the light of distant stars is so intuitively understandable and tempting that it still lives in the minds of many as the simplest and most obvious solution to the paradox. Why go through all this trouble with big bangs and expanding spaces when you can simply assume that there is a giant, impenetrable veil between us and distant stars? This hypothesis looks damn attractive. We know that dust exists in space. We see it with our own eyes. Majestic dark nebulae, such as the famous Horsehead Nebula in the constellation Orion, or the Coalsack Nebula in the Southern Cross. These are they, giant clouds of cold gas and tiny dust particles, silicates and carbon compounds. They truly act as a cosmic curtain, appearing as dark silhouettes against the background of bright star fields or luminous nebulae behind them. They absorb and scatter light, creating some of the most dramatic and beautiful landscapes in the galaxy. So why not assume that interstellar and intergalactic space is filled with such diffuse but all-pervading dust? Let's follow this logic. Here is the light from a very, very distant star flying towards us. On its way, it encounters a dust particle and is absorbed by it. Light from another star encounters another dust particle, and so on. If space is infinite and uniformly filled with dust, then sooner or later, light from any star, however distant, will be intercepted. Our gaze, directed at any point in the sky, will inevitably hit not the surface of a star, but an opaque wall of dust. The problem is solved. The sky is dark because it is covered in cosmic smog. It is simply elegant and requires no revolutionary revisions of the foundations of the universe. The universe can still be infinite, eternal, and static. Olbers' paradox is neutralized. The case is closed, but don't rush. The great detective called science never trusts simple answers. He always asks one more, the most tricky question: what's next? And in this case, the question sounds like this: and what happens to the dust particle after it absorbs a photon of light? It is here that all the neat buildings of the dust hypothesis begin to crack. The most fundamental and relentless law of nature comes into play, which cannot be circumvented or deceived. The law of conservation of energy, one of the pillars of thermodynamics. It states, energy cannot disappear without a trace. It cannot be destroyed. It can only transform from one form to another. When a tiny particle of cosmic dust absorbs a photon, the energy of that photon doesn't disappear. It's transferred to the dust grain, causing its atoms to vibrate faster. Simply put, the dust grain heats up. One photon is a minuscule amount of energy, and the heating will be microscopic. But we are talking about Olbers' paradox. In his eternal and infinite universe, an infinite stream of photons from an infinite number of stars falls onto this dust grain. It absorbs light second by second, year after year, for all eternity. And it heats up. It gets hotter and hotter. What does any physical body do when it's heated? It begins to glow. A cold piece of iron is black. Heat it in a blacksmith's forge, and it will first turn dark red, then orange, yellow, and finally, dazzlingly white. This process is called thermal radiation. Any object with a temperature above absolute zero emits electromagnetic waves. The higher its temperature, the more energy it radiates, and the shorter the wavelength of that radiation. Our cosmic dust grain, by absorbing stellar energy, is obliged, according to the laws of thermodynamics, to begin radiating that energy back into space itself. It will heat up until it reaches thermal equilibrium, a state where the amount of energy it absorbs will be exactly equal to the amount it radiates. In the conditions of an eternal universe flooded with an infinite stream of starlight, this equilibrium temperature would be very high. The dust would glow white-hot. And what is the result? A veil of dust, which was supposed to save us from the paradox, turns into a source of light itself. It absorbs visible light from the stars, but, in return, emits its own thermal light. Yes, perhaps it will be in a different spectrum, for example, infrared, but that doesn't change the essence. The paradox doesn't disappear, it just changes color. Instead of a sky blazing with visible light, we would have a sky blazing with infrared light. The total energy reaching every point in space would remain the same. We would still be living inside a giant red-hot oven, just invisible to our eyes, but perfectly perceptible to any thermometer. Thus, the dust hypothesis is not a solution, but merely a stay of execution. It doesn't eliminate the problem. It merely masks it, shifting it from the visible spectrum to the invisible. Dust in space is not a shield, but a transformer. It takes energy in one form and gives it back in another. For the darkness to be real, one must not simply block the light. One must ensure that this infinite stream of light does not exist in the first place. And this brings us back to the only possible conclusions. Either the stream had a beginning, a finite age of the universe, or the energy of the stream is lost along the way. Cosmological redshift. The false trail led us to a dead end, but it performed an important job. It showed us the depth of the problem and the rigor of the scientific approach. It taught us that intuitive answers are not always correct, and that any hypothesis must withstand cross-examination by all fundamental laws of physics. Dust was a perfect suspect, but it had an ironclad alibi provided by thermodynamics itself. The case remains open, and for its final resolution, we will need something even more astonishing. We have come a long way. We have demolished the walls of eternity and staticity. We have united the power of two great discoveries, the birth of the universe and its expansion, to explain why the night is so enchantingly dark. We have exposed the false suspect, cosmic dust, showing that it cannot be the solution. It seems the case is closed, the mystery is solved, and we can draw a line under it. But now I ask you to prepare yourselves, because everything I have said up to this moment has been merely preparation for the main, most astounding turn in our story, for a secret that transforms the entire problem into its complete opposite. The fact is, the night sky is not black. This statement sounds like pure madness, like a provocation. We have just spent so much effort explaining this very blackness. But science, in its pursuit of knowledge, is like a mountaineer who, having climbed one peak, sees that beyond it lies an even higher and more breathtaking mountain. Olbers Paradox has been resolved, but the solution turned out to be far stranger and more beautiful than anyone could have imagined. The story of this incredible discovery began not in a majestic mountaintop observatory, but in a far more prosaic place, in the laboratories of Bell Company in New Jersey in the mid-60s of the 20th century. Two radio astronomers, Arno Penzias and Robert Wilson, were tuning a large horn antenna, originally built for satellite communications. Their goal was to map the radio emission of the Milky Way, but they encountered a problem, an inexplicable, persistent, all-pervading problem. Their highly sensitive receiver was picking up a constant, faint background noise, a hiss. No matter where they pointed their antenna, towards the center of the galaxy, its edges, or the seemingly most empty parts of the sky, the noise did not disappear. It was everywhere. It was absolutely uniform in all directions. Penzias and Wilson were first-class engineers. They assumed the problem was with the equipment. They checked all connections. They reassembled the electronics. They even climbed inside the giant horn and cleaned out its hell, as they called it, a white dielectric material left by a pair of pigeons that had taken up residence there. But the noise remained. It wasn't coming from New York, nor from the sun, nor from our galaxy. It was coming from everywhere. It was as if the very emptiness between the stars was quietly but persistently humming at a certain microwave frequency. At the same time, just a few dozen kilometers away, at Princeton University, a group of theorists led by Robert Dicke was working on the exact opposite problem. Based on the ideas of a hot Big Bang, they concluded that there should be residual thermal radiation left over from the earliest fiery epoch of the universe. They calculated that due to trillions of years of expansion, this ancient glow should have cooled to a temperature of only a few degrees above absolute zero and should manifest itself today as a faint microwave radiation uniformly filling the entire sky. They had even begun building their own radio telescope to try to capture this signal. And then, by a happy coincidence, one of the scientists heard about the mysterious noise that the engineers at Bell couldn't get rid of. The two pieces of the puzzle clicked together with deafening clarity. Penzias and Wilson, trying to eliminate interference, had accidentally stumbled upon the greatest discovery in cosmology. They had heard the echo of the creation of the world. What they discovered is what we today call the cosmic microwave background radiation, or relic radiation. And this is the definitive, most elegant answer to Olbers' paradox. To understand its essence, we need to take the most distant journey back in time, to an era when the universe was only about 380,000 years old. In those times, the universe was not dark and empty. It was the complete opposite. It was an unimaginably dense and hot, blinding fog. The temperature reached several thousand degrees. All matter existed in the form of plasma, a swirling soup of atomic nuclei, mainly hydrogen and helium, and free electrons. Photons, particles of light, were trapped in this soup. They couldn't travel even a millimeter without encountering a free electron and changing their direction. Light was chained to matter. The universe was absolutely opaque, like the surface of the sun or a dense fog. But the universe continued to expand and cool. And when the age of the world reached the mark of 380,000 years, the temperature dropped to a critical value. There was no longer enough energy to keep the electrons in a free state. They began to be captured by atomic nuclei, forming the first neutral atoms in history. This process is called recombination, and at this moment, a miracle happened. The fog dispersed, the obstacles to light disappeared. Photons, which had been trapped in the plasma prison until then, were set free. Imagine a giant stadium filled with people running and pushing around randomly. If you try to throw a ball from one end to the other, it will immediately hit someone. But then, at a command, everyone freezes in place. Now you can throw the ball, and it will fly unimpeded across the entire stadium. Recombination was such a freeze command for the universe. And this light, the light emitted at the moment the universe first became transparent, was released and has been traveling through space ever since. It flies towards us from all directions, because in that era, the entire universe was this glowing fog. Wherever we look, we are looking at this ancient shore of the recombination era. But why don't we see this dazzling radiance? We already know the answer: the great stretching. In the more than 13 billion years that this light has traveled to us, the universe has expanded more than 1,000-fold, and the light wave has stretched along with it. Incredibly hot, bright, visible radiation with a temperature of 1,000 degrees was stretched, cooled by cosmological redshift, to a state of cold microwaves corresponding to a temperature of only 2.7 degrees above absolute zero. Here is the main secret. Olbers' paradox was correct in its initial premise. The sky is indeed uniformly filled with light. The entire celestial sphere truly glows, but it is not the light of nearby and distant stars. It is the afterglow of the Big Bang itself. It is invisible to our eyes, which evolved to see a narrow band of light from our sun. But it is absolutely real. If our eyes were capable of seeing microwaves, the night sky would appear to us not black, but a uniformly shining, dazzling canvas. The darkness we see is merely an illusion, created by the limitations of our vision. Space is not empty and not dark. It is flooded with the light of its own birth. We have unraveled the great mystery of the night. We have understood that the darkness we see is a complex narrative of the world's birth and growth. It is woven from two main threads: the finite age of the universe, which limits our visibility, and its expansion, which stretches and weakens the light of distant stars. And, as the cherry on top, we have discovered that this very darkness is not dark at all, but is filled with a microwave radiance invisible to us, the echo of the Big Bang. It would seem we have peered into the very essence of the void between the stars, but here awaits us another, perhaps the most dizzying discovery of modern science. This void, this blackness that we have tried so long to explain, is actually not empty at all. On the contrary, It contains almost everything that makes up our universe, and this is the greatest mystery that humanity has ever encountered. Let's first assess how empty intergalactic space actually is. If we take all the ordinary matter we know, the atoms that make up stars, planets, nebulae, and us, and spread it uniformly throughout the observable universe, its average density will be depressingly low. Approximately 1 hydrogen atom per cubic meter. This is a vacuum that is billions of times more rarefied than the best vacuum we can create in terrestrial laboratories. This is almost perfect nothingness. And for a long time, it was believed that this nothingness constituted the main part of the cosmos. But reality turned out to be far stranger and more layered. The first hint that we were missing something appeared back in the 1930s of the 20th century, thanks to observations by the Swiss-American astronomer Fritz Zwicky. Studying a galaxy cluster in the Coma Berenices constellation, he noticed a strangeness. The galaxies in this cluster were moving too fast. They were hurtling around each other at such speeds that the gravity of all visible stars, gas, and dust was utterly insufficient to hold them together. By all laws of Newtonian mechanics, this cluster should have long ago flown apart in all directions, like drops of water from a wheel spinning too fast. For it to remain stable, there had to be an enormous amount of some hidden, invisible mass that would bind it together with its gravity. Zwicky called this mysterious substance dunkle materie, dark matter. At the time, his work was largely ignored, but decades later, in the 1970s and 80s, another female astronomer, Vera Rubin, obtained irrefutable evidence for the existence of this matter by studying the rotation of individual spiral galaxies. She discovered that stars on the outskirts of galaxies were orbiting the center at almost the same speed as stars near it. This completely contradicted expectations. After all, if all the mass were concentrated in the visible stars at the center, then the outer stars, like distant planets in our solar system, should have moved much slower. The fact that they were moving so fast meant that they were under the influence of a powerful gravitational field from something we couldn't see. Galaxies turned out to be immersed in giant spherical halos of this invisible dark matter. It does not glow, it does not absorb light, it does not reflect it. It interacts with our world in only one way, through gravity. Today, we know that this mysterious dark matter constitutes about 27% of all mass energy in the universe. Think about it. For every kilogram of ordinary matter that makes up us, our planet, and all the stars in the sky, there are more than 5 kilograms of invisible, mysterious substance whose nature we do not understand. It serves as the invisible framework, the gravitational glue, on which visible matter gathers like pearls on a string, forming galaxies and their clusters. The darkness between the stars is actually permeated with this invisible substance. But that's not all. In the late 1990s, astronomers studying distant supernovae made a discovery that shook the foundations of cosmology. For the second time, they were trying to accurately measure how the expansion of the universe was slowing down over time. Everyone expected that the gravity of all matter, including dark matter, should be slowing this process, like a stone thrown upwards slowing down under Earth's pull. But the results were the exact opposite. It turned out that the expansion of the universe was not slowing down, it was accelerating. It was like throwing a stone and seeing it, instead of slowing down and falling, begin to fly upwards faster and faster. There must be some force, some energy, spread throughout space that acts as anti-gravity, pushing galaxies apart and causing the universe to inflate at an accelerated rate. This even more mysterious entity was named dark energy. It is unlike anything we know. It does not clump together like ordinary or dark matter. It appears to be a property of the vacuum itself, of empty space, and its quantity is simply astonishing. According to the latest data, this dark energy constitutes about 68% of all mass energy in the universe. Now, let's put the puzzle together. All ordinary matter, everything we see, everything we can touch, all the stars, galaxies, planets, and nebulae make up less than 5% of the total mass energy of the universe. About 27% is invisible dark matter, which binds the cosmos together with its gravity. And the remaining 68% is the mysterious dark energy, which pushes it apart, accelerating its expansion. This means that 95% of the contents of our universe is hidden from us in darkness. That very blackness of the night sky, which we considered empty, is actually the main stage where the most fundamental and most mysterious forces in nature operate. It is not empty. It is filled to the brim with the greatest mysteries of science. When we look into this darkness, we are looking into an ocean of the unknown. We are just a tiny bit of foam, 5% of the foam on the surface of this bottomless dark ocean. Our visible universe is just rare sparks on a giant invisible continent. And understanding the nature of dark matter and dark energy is the main challenge for 21st century physics. We have made a grand journey from a simple question to the most complex concepts of modern cosmology. We have seen that darkness is not an absence, but a presence, the presence of history, the laws of physics, invisible matter, and mysterious energy. But now, at the end of our journey, let's turn the telescope in another direction, from distant galaxies and the echoes of the Big Bang to ourselves. What does this majestic, meaningful darkness say about us, about humanity, about our place in this vast, cold, and, at first glance, indifferent cosmos? Perhaps it is here, in this existential reflection, that the deepest lesson of the night sky lies. Firstly, darkness is our window into the past. And this is not just a beautiful metaphor. When we look at the night sky, we are the only known beings capable of consciously peering into the history of the universe. The light from a star you are looking at could have been emitted in the year of your birth, or during the time of the Roman Empire, or even before the dinosaurs appeared on Earth. This blackness, separating the glowing points, is not just space, it is time. It gives us perspective. It reminds us that our lives, the history of our civilization, even the history of our species, are but a fleeting flash against the backdrop of cosmic epochs. This knowledge may seem humbling, but it also has grandeur. It connects us to the very beginning of time. It makes us not just inhabitants of a planet, but witnesses to a cosmic drama. Secondly, darkness emphasizes our incredible isolation and, at the same time, our uniqueness. Look at this abyss, these tiny distant lights, separated by unimaginable gulfs of emptiness and darkness. We live on a small, warm blue island of light and life in the midst of this boundless, cold, and dark ocean. For a long time, this realization generated fear, a sense of cosmic loneliness. But today, we can look at it differently. This darkness is what makes our world so precious. Our island is not a prison, but a treasure. Perhaps somewhere out there, in this darkness, there are other such islands. But until we find them, ours is the only known home for life, for intelligence, for consciousness. The darkness around does not diminish our light, but rather makes it brighter and more significant. And thirdly, and most astonishingly, the darkness of the night sky is directly linked to our biology, to how we are made. Why do our eyes see precisely that narrow spectrum of light that we call visible? Why don't we see radio waves or X-rays? The answer is simple. We are children of our sun. Our star, like any other, emits in a wide range of waves, but the peak of its radiation falls precisely in that visible spectrum. Over billions of years of evolution, life on Earth has adapted to use the most abundant and efficient source of energy. Our eyes are biological telescopes perfectly tuned to the frequency of our parent star. This is precisely why the sky is dark to us. We evolved to see the bright light of our star, not the faint, stretched echo of the Big Bang or the dim glow of distant galaxies. Our perception of reality is a direct consequence of our local cosmic environment. If we had evolved on a planet around a red dwarf, our visible spectrum would be shifted into the infrared region. If we were beings born in a gas nebula, perhaps we would see in the radio range. The darkness of the night sky is a mirror reflecting not only the history of the universe, but also the history of our own evolution. It tells us, you see the world this way because you are a product of this particular star on this particular planet. Our subjective reality is forged in the crucible of objective laws of the cosmos. Thus, looking into this deep velvet darkness, we are looking into a triple mirror. We see the past of the universe. We see our present, a fragile island of light in an endless ocean. And we see ourselves, beings whose sensory organs and consciousness itself are a product of this great cosmic context. Darkness is not what separates us from the universe. On the contrary, it is what connects us to it in the most profound and intimate way. It is a reminder that we are not just in space, we are space becoming aware of itself. We started with a simple, almost childlike question: why is it dark at night? And ended at the very frontiers of knowledge, peering into the nature of reality, into the mysteries of dark matter, and into the mirror of our own existence. We saw that the answer to this question is not a single sentence, but an entire epic, the greatest narrative ever told. It is a historical document. The black ink on the parchment of night tells us about the birthday of the universe. It testifies that our world had a beginning, that very fiery moment 13.8 billion years ago, the light from which we are still bathed in the form of invisible microwave background. It is a chronicle of life. Darkness is a trace of the continuous growth and evolution of the cosmos. It tells us about the great expansion of space-time, which stretches light, diminishes its energy, and drives galaxies further and further apart. This dynamic transforms a potential fiery hell into the calm, cold beauty we observe. It is a catalog of hidden treasures. In this darkness, like in a giant safe, lie the greatest mysteries of science. 95% of the universe's content, dark matter, which shapes the structure of the cosmos, and dark energy, which dictates its fate, are hidden in this blackness. It is not empty. It is full of mysteries yet to be unraveled by future generations of scientists. And finally, it is a philosophical mirror. Darkness tells us a story about ourselves, about our fragile yet precious place in the universe, about our unique consciousness capable of asking such questions and seeking answers, about our very biology, attuned to the light of our native sun. So the next time you go outside on a clear night and look up at the sky, don't think of darkness as the absence of something. Think of it as the presence of everything. Think of it as the most complete and honest history book of creation you have ever read. Its pages are not written in letters, but in the laws of physics. Its chapters are epics, lasting billions of years. And its main character is the universe itself, which, through this calm, majestic darkness, tells us its own story. A story that began with a blinding flash and continues to this day. And we are part of it. Standing here on this small planet, we have the incredible privilege of being its readers. And perhaps, one day, we will be able to write our own chapter in it. And here we stand at the summit. The path was long and winding. It led us through labyrinths of logic and through the epochs of cosmic history. We started with a simple, deceptively naive question, and having found its answer, we felt an abyss of new knowledge open up beneath our feet. We conquered Olbers Paradox. We looked into the face of darkness and made it tell its story. A story of birth, of expansion, of invisible light and invisible matter. It seems the book is closed, its last page turned. We can exhale with satisfaction, with that pleasant feeling of completion that a solved puzzle brings. But the universe, like the greatest storytellers, never puts a final period. Every answer it gives is merely a prelude to a new, even grander, and more incomprehensible story. And the very darkness we think we understand continues to whisper. And if we listen carefully enough, we will hear that its story is far from over. It tells us not only about the past, but also about the future and about the darkness that lies beyond our current understanding. The first whisper we hear comes from a distant, unimaginably distant future. It tells us about the fate of this very darkness. We have learned that the expansion of the universe is not just continuing, it is accelerating, driven by mysterious dark energy. This discovery, made at the turn of the millennium, has staggering implications for the future of the night sky. Today, we live in a golden age of cosmology. We can see millions, billions of other galaxies. We can study them, admire them, feel like part of this grand cosmic archipelago. But this is a temporary luxury. The accelerating expansion is a death sentence. It means that right now, at this very second, distant galaxies are crossing an invisible line, our cosmic event horizon, and disappearing from our field of view forever. Their light, sent to us after crossing this line, will never reach us, because the very space between us and them will expand faster than the speed of light. Imagine standing on the deck of a ship, and all the other ships in the ocean are not just sailing away from you, but are being carried away by an ever faster current. First, those on the horizon disappear, and then those that were closer. After a while, no matter how hard you look through the most powerful binoculars, you will see nothing but waves. Your world will become empty. The same awaits our galaxy. Hundreds of billions of years will pass. The sky we know today, dotted with the hazy specks of distant galaxies, will begin to empty. One by one, they will fade, crossing the horizon. First, the most distant quasars will disappear, then entire clusters of galaxies, then our closest neighbors. Eventually, in about 100 to 200 billion years, all galaxies beyond our local group, a small cluster gravitationally bound to the Milky Way and Andromeda, will become invisible to us. And then even greater loneliness. Our local group will eventually merge into a single giant elliptical galaxy, which futurists sometimes call Milkway. And for hypothetical observers living in this galaxy in 1 trillion years, the universe will look completely different. They will look at the sky and see only the stars of their own galaxy. Beyond it will stretch an absolute, impenetrable, eternal darkness. There will be no signs of other galaxies. There will be no redshift that might suggest expansion. Even the cosmic microwave background radiation, the echo of the Big Bang, will by then have stretched so much that its wavelength will become larger than the size of the observable universe itself, and it will become absolutely undetectable. These future astronomers, no matter how brilliant, will be trapped in their own version of Olbers' Paradox. But on the contrary, they will look at the sky and arrive at the only logical conclusion for them. Their galaxy is the entire universe, a vast, static, eternal island of light in an infinite void. The entire great story of the Big Bang, of expansion, of cosmic evolution, will be lost to them forever. The darkness that tells us a story today. One day, it will erase that story. This is the first chilling whisper about a future where knowledge will be lost and the cosmos will become unimaginably lonely. The second whisper comes not from the future, but from the very structure of the darkness that surrounds us right now. By solving Olbers' Paradox, we, like careless archaeologists, opened a tomb from which two far more formidable specters escaped: dark matter and dark energy. We explained the visible darkness, but at the cost of this explanation was the realization that we live in a world made up of 95% darkness of a completely different kind, the darkness of our own ignorance. Think about it. Everything we know, everything our science is built upon, protons, neutrons, electrons, photons, this is only a paltry 5% of the total picture. We explained why the void between the stars does not shine, but we have no idea what this void itself consists of. What is dark matter? Is it some kind of exotic type of particles that interact with us only through gravity? Perhaps it is so-called WIMPs, weakly interacting massive particles, or axions, or sterile neutrinos. All over the world, deep underground, in former mines and tunnels, scientists are building incredibly complex ghost traps, detectors cooled to temperatures close to absolute zero, hoping to catch at least one of these particles passing through the Earth and register its weak collision with ordinary matter. It's like trying to hear the fall of a single snowflake during a deafening storm. And dark energy is a mystery of an even deeper, almost philosophical level. What is this force that causes the very fabric of space to expand at an accelerating rate? Is it the energy of the vacuum itself, as Einstein predicted? If so, then why is its value exactly what we observe? Theoretical calculations give a value that differs from the observed value by 120 orders of magnitude. This is the largest discrepancy between theory and experiment in the entire history of physics. Or perhaps it is some new fifth fundamental field pervading the universe, so-called quintessence. Or perhaps our understanding of gravity on cosmic scales is fundamentally flawed, and general relativity is just a special case of a more general theory. This is a double mystery. This is the true darkness of modern cosmology. It whispers to us that the solution to Olbers' paradox was only the first step into a much darker and more entangled forest. We cleared a path and stepped into a clearing only to see that endless, untrodden thickets stretched around us. This darkness tells us about the limits of our knowledge. It humbles our pride and reminds us that we are still children playing on the shore of a vast, unknown ocean. And finally, there is a third whisper, the quietest, the closest, and perhaps the most alarming. It speaks not of the future of the universe, nor of the mysteries of physics. It speaks of the future of our ability to see this very darkness. We, people of the 21st century, may be the last generation in history that can still see the night sky as Aristotle, Galileo, and Olbers saw it. The very darkness that carried so much information, so much history and poetry, is disappearing, and we are erasing it ourselves. Our cities, our roads, our factories, and our homes emit a colossal amount of artificial light into the sky. This light scatters in the atmosphere, creating a constant light pollution above us, an orange dome that hides the stars. For billions of people on the planet, the Milky Way is no longer a real object in the sky, but a picture from a textbook. We have traded the majesty of the cosmos for the dim glow of streetlights. In our strive to conquer our small local night darkness, we are erasing the great cosmic darkness that is our window to the universe. This third whisper is a warning. It says that by unraveling the mystery of darkness, we risk losing that darkness itself as a source of inspiration and knowledge. We are drowning the quiet whisper of the universe in the deafening noise of our own civilization. We are becoming voluntary prisoners of our own artificially lit cave, turning away from the shadow play of the cosmos unfolding above our heads. Perhaps the greatest paradox of our time is that, having understood how valuable and informative darkness is, we are destroying it with unprecedented speed. So, the next time you find a place where you can still see a truly dark sky, listen. Listen to these three whispers, to the whisper of a distant, lonely future, to the whisper of bottomless mysteries hidden in the very fabric of reality, and to the quiet, sad whisper of disappearing beauty. And you will understand that the story of darkness is not over. We are merely standing at its threshold, and its most important chapters are yet to be written. And whether they will be written at all depends not only on the universe, but also on us. It is the year 2050, and we invite you to become participants in one of the most fascinating expeditions, whose mission is to colonize another planet. As part of a team of pioneers, you ascend to give a start to one of the most risky, but at the same time extremely significant journeys in your destiny, both for every team member and for all of humanity. Do you feel ready? 40 million kilometers away, a world of heat and acid awaits you, the kingdom of the second planet from our star, the sinister double of Earth, Venus. And it is about its colonization that we will talk today. Exhausting months of travel are behind us. We have arrived. Our starship, with the crew on board, approaches the planet with the goal of occupying its orbit. What, in principle, do we know about this world? What awaits the team members? In short, Venus is the second planet from the Sun, and the average temperature there reaches approximately 460 degrees Celsius, which exceeds the temperature at which lead melts. A significant portion of organic compounds also cannot maintain their structure at such heat. For comparison, on Mars, the average temperature is minus 40 degrees Celsius. However, comparing it with Mars doesn't make much sense, because Venus, considering its size and mass, is classified as an Earth-type planet. What is the similarity, and what is the advantage of the planet named after the goddess of love over the red planet, named after the god of war? To begin with, the radius of Venus is about 6,000 kilometers. This is 95% of the radius of the Earth. Its mass reaches a little more than 81% of Earth's. At the same time, the acceleration of free fall there is almost 9 meters per second squared, while on our native planet it approaches 10. On Earth, humanity is protected from deadly solar radiation by the ozone layer and the magnetic field generated by the core of our world. Venus, however, has a noticeably weaker magnetism. Nevertheless, at the boundary of its atmosphere, there is an ionized layer, forming a sufficient barrier so that additional protective measures are not required. In other words, it's almost Earth, but not quite. Venus has an atmosphere that is 90 times denser than Earth's, and for humans, it is extremely aggressive and poisonous. And the pressure there is comparable to the pressure at a depth of 1 kilometer in Earth's ocean. Going to the surface is not the best idea if you don't want to be boiled like an egg in an acid solution. But do not worry. Landing on the planet itself is not part of the crew's plans. Day 1. The planet's gravity has successfully captured the spaceship, and it has occupied its orbit. The subsequent task is to enter the atmosphere. Here it is extremely dense, which will be beneficial for braking during descent. To establish a colony on Mars, for example, it is necessary to land on its surface. For Venus, it will be enough to enter the upper atmospheric layers and begin creating a settlement whose goal is to remain in the sky. During return to Earth, spacecraft use aerodynamic braking and then gliding or parachute descent. These same proven technologies are used on Venus because at a significant distance from the surface, the density of its atmosphere is similar to Earth's. Since this is the final goal, the ship's crew reduces speed to acceptable values and transitions to controlled flight on the final leg of the journey. By the way, in the rarefied Martian atmosphere, both parachutes and wings will be less productive. Braking with rocket engines will be required, which is a more complex and costly task. Day 35. The ship's crew has completed a comprehensive check of the airship's equipment systems. It begins to be filled with a gas mixture of oxygen and nitrogen, which ensures its buoyancy. This airship will become home for the very first settlers on Venus. It will drift around the planet, carried by natural winds. Venus's atmosphere consists primarily of carbon dioxide. However, at an altitude of 50 to 70 kilometers from the surface, there is an unpleasant surprise. We are talking about clouds of sulfuric acid. The sensation of burning in the eyes is guaranteed. Moreover, because of these clouds, it is impossible to see through them from the outside. By the way, the material for the balloons is dense 4-layer fabrics, covered on the outside with a substance resembling silver Teflon. It demonstrates sufficient resistance to acid. Our pioneers have accomplished their first and significant mission, confirming that life in the clouds of Venus is a feasible reality. The temperature here is analogous to the Mediterranean region on Earth, and the pressure of 1 bar is also identical to Earth's. Such conditions exist at an altitude of 50 kilometers above the surface, above the cloud layer. The airship performs the function of housing, and quite a comfortable one, although we don't promise tennis courts. There is no need to expend energy on heating, as there is plenty of sunlight here. It is not for nothing that Venus was nicknamed the morning star, because its clouds reflect the sun's rays perfectly, making it bright for observers from Earth. Venus is located significantly closer to the sun, and as a consequence, it receives a huge amount of solar energy. The intensity of radiation there is 4 times higher than, for example, on the red planet. The efficiency of solar panels will also be as much higher compared to Mars. Day 354. Colonists live and work inside the airships. By this time, panels with solar cells have already been installed directly on the upper parts of the balloons, and some of them have been extended to the sides of the gondolas. Since the solar cells are above the cloud layer, any interference with the light reaching them is excluded. In addition, the abundance of sun positively affects the growth of flora, which is important for generating oxygen and food. The sun will also be the only source of energy for future industry in the floating factories. On Mars, incidentally, colossal areas would have to be occupied by solar panels to generate the required amount of energy. Moreover, powerful and prolonged dust storms can have a detrimental effect on Mars's energy supply, which cannot be said about Venus. Day 545. The distance from Earth to Venus ranges from 38 to 261 million kilometers. On this day, a new launch window opens, which will appear more often than for flights to Mars. Another mission departs from Earth to deliver new crew members and vital life support systems. Additional solar panels, backup fuel, oxygen, water, waste disposal system, medical supplies, as well as tools and equipment for new research. We have been on Venus for 1,000 days. A large-scale media project is launched on Earth in honor of the 1,000th day of life on Venus. Earthlings are communicating via satellite channel with Venusians. The communication network deployed in orbit around the planet works flawlessly. This is a real breakthrough and a magnificent date for celebration, but do not get too carried away. Day 1134. From the floating laboratory, research probes, resembling terrestrial deep-sea bathyscaphs in appearance, are periodically lowered to the planet's surface. Warning: do not attempt to penetrate them. During descent, electricity is accumulated along the way. To do this, a impeller is extended outward into the oncoming gas flow. It begins to rotate, and the electric generator produces electric current. By accumulating energy in batteries, it is subsequently used to illuminate Venus's landscapes with spotlights and flashes. Indeed, eternal twilight prevails on the planet's surface, but even there something amazing can be found. Day 205. The first incident is registered, a puncture of the airship's envelope, which led to depressurization. Fortunately, you have an alibi. Attached to the edges of the platform where the settlers live is a giant spherical envelope, limiting the airspace of the island. It is made of several layers of synthetic film. Gas mixtures circulate between them, containing indicator substances that signal possible damage to the envelope. It was precisely by such an indicator that the puncture was discovered. But there will be no decompression problems in the airspace. Identical pressure inside and outside means that upon depressurization, air leakage will occur slowly. Even with significant hull damage, it would take more than a month for the air loss to reach a critical level, which provides a solid buffer for repairs or evacuation. The emergency situation was successfully resolved, and the perpetrator was jettisoned to the surface. Day 2570 arrived. By this time, the technological process of extracting the most valuable and vital resource, water, had long been thoroughly established on Venus. Water vapor in the form it exists in Earth's clouds is simply not present here. However, as compensation, nature has provided an almost inexhaustible excess of concentrated sulfuric acid. The colony's chemist-scientists, true wizards of molecular transformations, employ several refined and highly effective methods to obtain precious moisture. A key method, for instance, is a reduction reaction using combustible carbon monoxide, which is also extracted from the atmosphere. In special pressurized reactors, the acid interacts with the gas and ultimately decomposes into sulfur dioxide, which is captured for further processing, carbon dioxide, and, most importantly, water, essential for all life. In addition to purely chemical methods, biotechnology also comes into play. Special strains of extremophile bacteria are cultivated in giant vats, greedily absorbing sulfur directly from the acid and releasing hydrogen sulfide as a byproduct of their life activity. Subsequently, through a whole cascade of subsequent chemical reactions, pure water is also extracted from this gas. This water, in turn, can be easily decomposed into its constituent oxygen and hydrogen using a proven electrolytic method when needed. Thus, the colonists provide themselves not only with water, but also with gas critical for breathing and highly efficient, environmentally friendly rocket fuel. Sulfuric acid, which is not at all difficult to obtain on Venus, is sufficient for launching and maintaining all these processes. In Venus's dense clouds, incredibly strong, thin nets made of acid-resistant composite material are constantly lowered, and aggressive sulfuric acid itself condenses on their surface, collecting in special collectors. Since the colonists experience no water deficit whatsoever, fish, artificially raised in enormous aquariums integrated directly into the residential platforms, have firmly established themselves in their daily diet. Moreover, entire fleets of aerostats designated for agricultural complexes have transformed into veritable hanging gardens. In their transparent hulls, bathed in soft, diffused light, genetically adapted strains of earth plants and vegetables are successfully cultivated using advanced aquaponics and hydroponics methods. So, a useful occupation can always be found here for every specialist. There is still no shortage of solar energy whatsoever. The aircraft, serving as homes and factories on Venus, have a key, invaluable advantage. They can drift eternally in dense air currents and will never fall to the surface, even during the infinitely long multi-month Venusian night. Day 3569 passed. With enviable and precisely calculated regularity, new transport ships from Earth head towards the planet, bringing fresh replenishment for the crew, new scientists, engineers, doctors, as well as unique and high-tech equipment. Other colonists, whose work shifts have ended, depart on the return journey with a sense of accomplishment, heading home to the shining Earth in the distance. By this time, the Venusian settler colony had completely transitioned to autonomous self-sufficiency. Active mining of various raw materials is underway, allowing for the production of everything necessary directly on site. Extracting any resources from the planet's depths remains extremely difficult due to the monstrous surface conditions. For this compelling reason, Venusians have learned to be content with and skillfully utilize what literally floats in the air, the gases that constitute the atmosphere. And this, as it turns out, is not so little. The clouds here consist primarily of the aforementioned sulfuric acid and hydrogen sulfide, but from them, as well as from the ubiquitous carbon dioxide, pure carbon, hydrogen, nitrogen, and sulfur can be obtained on an industrial scale. The intelligent application of these basic chemical elements opens truly boundless possibilities. For example, carbon serves as an ideal base for creating extremely strong synthetic fibers, enabling the production of a wide variety of clothing and footwear. Just imagine for a moment that your personal wardrobe might one day include elegant trousers or cute and comfortable ballet flats, literally woven from the particles of distant Venus. The combined use of carbon and hydrogen allows for the easy synthesis of any hydrocarbon gases, including methane and ethene. The former is used as the primary rocket fuel for interplanetary flights, the latter as an efficient reactive mass for compact maneuvering and positioning engines of spacecraft. In addition, chemical engineers, using abundantly available gases, produce a wide spectrum of various plastics and create unique composite materials based on them, which, in terms of strength and lightness, successfully replace traditional metal. Such high-tech industry does not require the bulky and heavy equipment characteristic of Earth factories. Day 7,689 passed. The Venusian colony has grown and now includes 1,000 permanent settlers. An incredible, enormous city in the form of a cluster of elegant silver airships majestically floats at a stable altitude of 50 kilometers from the surface of the planet, which is no longer so hostile. Due to the unique specifics of Venus, the daily life and very survival of the colonists depend to a significant, if not decisive, extent on the achievements of the chemical industry. People independently produce ultra-strong materials for the construction and expansion of flying cities. They obtain water for drinking and irrigation of their hanging gardens, for assembling complex equipment. Perhaps the only things still periodically delivered from Earth are small but concentrated volumes of specific nutrients and microelements for the greenhouses, as well as some particularly complex and unique equipment for chemical plants. Since the planet is noticeably closer to Mars, cargo delivery there is a relatively simple and economical task, especially since it does not involve the construction of giant industrial enterprises. People have already mastered the production of compact modular units for carrying out all necessary chemical processes. True, entire factories are not transported. There is simply no need for it. Modular blocks, like construction kit parts, are delivered and assembled into a single whole directly in Venus's atmosphere. Specialized flying cranes, such as an impressive saucer-shaped aerostat with powerful propellers, are used for their precise assembly and movement. For example, an Earth prototype, the Skylifter apparatus with a diameter of 150 meters, was able to lift a load of 150 tons during tests in Earth's atmosphere. On Venus, however, its carrying capacity increases manifold, as the lift force increases significantly in the dense carbon dioxide atmosphere. Day 918 arrived. The colony's population has surpassed the symbolic mark of 100,000 people. This is no longer just a scientific station, but a fully fledged living society. Entire families now reside here permanently, working selflessly and passing on their experience from generation to generation. And even, to the surprise of newcomers, they successfully sell aromatic Pakistani food in small, cozy cafes. The flying islands have all the necessary infrastructure for a comfortable life. A modern maternity hospital, where the first native Venusian babies are born. Well-equipped hospitals, schools where children study both Earth and local sciences, various retail outlets, and even a small but very popular souvenir shop made from local materials. Don't forget, by the way, to bring back a couple of magnets with captivating and slightly melancholic Venusian landscapes for your loved ones when returning to Earth. The 10,000th day has come. On their days off, Venusians can now afford leisurely strolls in real picturesque parks floating in the sky. These colossal circular platforms, reaching several hundred meters in diameter, are constructed from incredibly strong yet lightweight cellular plastic structures. However, they are covered from above by a thick layer of fertile soil on which familiar earth plants are carefully grown, creating the illusion of a corner of their native world. These are a kind of small floating villages, where cozy houses are freely scattered amidst shady gardens and fragrant park areas. It seems you are truly happy, and life here is not standing still. It continues its turbulent and multifaceted development. Yes, this is exactly the world that could one day become our shared reality. All the described projects are technically feasible in the foreseeable future. Undoubtedly, their implementation is extremely costly and incredibly complex, but history convincingly proves that fundamental science has always readily returned the resources invested in it, bestowing upon humanity truly astonishing, previously unimaginable possibilities. At the present moment, of course, there are no technologies that would allow us to totally and purposefully change the conditions and climate on entire planets. We undoubtedly desperately need these technologies, as no one can give firm guarantees that on our native Earth, even due to absolutely natural reasons beyond our control, everything will always remain prosperous. And humanity needs, so to speak, a backup airfield, a training ground for survival and creation skills in other worlds. Venus in this regard is an excellent, almost ideal candidate. Of course, there are certain and very weighty ethical considerations according to which we have no moral right to intrude into pristine alien worlds and radically transform anything there, especially not on Venus, which could have its own hidden life forms. Be that as it may, one cannot deny the fact that the spread of our species across the entire surface of the Earth has irreversibly altered its pristine appearance in many ways. Our native planet would look significantly different today if intelligent humans had continued to modestly inhabit a single point in the world without spreading their influence. I would like to separately mention the research missions that are already in the active preparation stage for studying Venus in the near future. These are Da Vinci Plus and Veritas, two promising and ambitious NASA projects. The main task of the Da Vinci Plus probe is to make a deep dive into Venus's dense, turbulent atmospheric layers and collect data that will help clarify how exactly it formed and changed over billions of years. Veritas, in turn, will use the most advanced radar technologies to create an unprecedentedly detailed three-dimensional map of Venus's surface while in orbit. Researchers worldwide harbor great hope that the results of these expeditions will make an invaluable contribution to our understanding of how Earth developed and evolved, and why it is currently a unique oasis suitable for life, while other worlds in our solar system remain lifeless. These crucial missions will be directed towards Venus between the years 2028 and 2030. Another extremely promising mission to this mysterious and still little-studied planet should also be noted, which, if there are no postponements, will launch in 2029. This is the large-scale project Venera D, which is the result of joint development by a Russian-American research group. One of the key and most intriguing tasks of this expedition will be to find a definitive explanation for the presence of an as yet scientifically unidentified ultraviolet absorber in the upper layers of Venus's atmosphere. This mysterious component, which theoretically could be the result of the life activity of giant colonies of aerobic bacteria in the planet's clouds, absorbs a significant portion of sunlight. Yes,